In the next couple of sections of the book, we'll talk about something called identities. Section 1.4 is an introduction to identities. First, we need to talk about what identities even are. Identities versus conditionals. A conditional equation is one that is true only under certain conditions. In other words, for certain values of the variable. For example, the equation x squared equals 4 is only true if x equals plus or minus true. So it is a conditional. In other words, it's true only under the condition that x is plus or minus 2. On the other hand, an identity is an equation that is true for all values in the domain of the equation. For example, the equation x squared equals x times x is true for all x values, so it is an identity. And the way I remember that is an identity is something where the two sides of the equation are identical. Similarly, the equation 3x over x equals 3 is true for all x values except x equals 0. Right? It's not true when x equals 0 because when x equals 0, the left-hand side of the equation is undefined. But x equals 0 is not in the domain of this equation, so it is still an identity. Now in trig, there are some identities that we need to know. There's going to be quite a few, but right now we'll just talk about the ones called fundamental trig identities. First, we have the reciprocal identities, and it's possible you might have even noticed some of these for yourself. For example, we define cosine of theta to be x over r, and then we turned around and defined secant of theta to be r over x. So we defined the secant basically as the reciprocal of cosine. So that's where these reciprocal identities come from. Cosecant of theta is defined to be r over y, whereas sine of theta is y over r. So cosecant of theta is 1 over sine of theta. And similarly, cotangent of theta is 1 over tangent of theta. Then we have two ratio identities. These you might or might not have noticed when we were defining the trig functions. So tangent of theta we define to be y over x, and if you look at sine of theta, which is y over r, cosine of theta is x over r. If you simplify that ratio, you get back to tangent. So tangent of theta is sine over cosine. Cotangent of theta similarly is cosine of theta over sine of theta. Then we have the Pythagorean identities. Sine squared of theta plus cosine squared of theta always equals 1. Tangent squared of theta plus 1 equals secant squared of theta whenever tangent and secant are defined. And 1 plus cotangent squared of theta equals cosecant squared of theta. And again, that's when both of those trig functions are defined. I just realized I talked through these without really giving you time to write them down. So I'm going to scroll a little bit slowly here through these and hopefully give you time to write them down. Okay, I hope that was enough time. One comment about the notation in the Pythagorean identities. When we write sine squared of theta, what we mean by that is compute the sine of theta and then square that output. Similarly, cosine squared of theta means find the cosine of theta and then square that value, etc. for all the trig functions. Some super good advice, I think actually from a different textbook. These identities should not merely be memorized, but should be known, just as you know your name rather than having it memorized. You want to be so familiar with them that you recognize variations of them. For example, sine squared of theta equals 1 minus cosine squared of theta. So we'll just go back up and I'll point out some of the common variations. So for these reciprocal identities, for example, secant of theta equals cosine of theta, equivalently, cosine of theta would be 1 over the secant of theta. Sine of theta would be 1 over the cosecant of theta, and tangent of theta is 1 over the cotangent of theta. So they're all reciprocals of each other. There aren't really any different forms for the ratio identities, but the Pythagorean identities have quite a few. And I think I'm going to give us some extra space for those. So, as was, I think, already mentioned, you'll want to recognize that cosine squared of theta equals 1 minus sine squared of theta. Let me do one more with cosine. If you take that one step further and solve for the cosine, you get cosine of theta equals plus or minus the square root of 1 minus sine squared of theta. Then moving on to sine, if you subtract cosine squared from both sides of that original identity, you have sine squared equals 1 minus cosine squared of theta. Taking square roots on both sides, we have sine of theta equals plus or minus 1 minus cosine squared of theta. And we have all the similar kinds of variations for tangent and cotangent and secant and cosecant, although you don't see the square root ones quite as much with the second two of the Pythagorean identities. So I'll just mention that you should at least recognize that tangent squared of theta equals secant squared theta minus 1. And cotangent squared of theta equals cosecant squared of theta minus 1. Oh, and there's also secant squared of theta minus tangent squared of theta equals 1. You get that just by subtracting tangent squared from both sides of the second Pythagorean identity. And similarly, cosecant squared of theta minus cotangent squared of theta equals 1. Now, I'm not suggesting that you necessarily memorize all these alternative forms. The note at the bottom of the page is basically encouraging you to memorize the original ones so well that you simply recognize variations of them.